All right, so continuing on, let me get a share screen going. So I wanted to talk today about rigid bodies. I mentioned them before. Rigid bodies are these non-deforming objects that respond to forces and collisions. And they're non-deforming in that whatever our object is, it's a sphere is always a sphere. This makes collisions easier. So we need some game object to which we've added a rigid body component. Generally, we'll also add a collider component to it, which I'll talk about in a while. And of course, if you want to see the object, it has to have a mesh filter and a mesh renderer. This is what lets us see the object. And optionally, we can assign a physics material to the collider component. So let's do that over in this little scene here. I've got this cube. And I have added a rigid body component to it. It has the mesh filter and the mesh renderer that let us see it. And I have a box collider on it. We'll talk about the specific colliders in a little bit. And the rigid body has certain properties. Primary among the rigid bodies is that they have a mass. This is the weight in kilograms. My little cube here has a mass of one kilogram. And one thing we do have to be careful of is interaction between objects whose mass ratios are greater than 100. So if I were to hit this cube with an object that weighed more than 100 kilograms, the physics might not be terribly accurate. It will still work, but the physics is not necessarily accurate. We have two kinds of drags. We have drag, which is its air resistance. It goes from 0 up to, I guess, infinity. And we have angular drag, which is its resistance to rotation. Here this little object has 0 linear drag and 0.5 angular drag. And we also see another setting here for used gravity. And let me just show you this without that clicked. And I have a little character in here that lets me run over here, oops. And I wanted to push it, but instead it got bumped by the ball. And you can see it's not using gravity, and so it doesn't fall. If I click this, the object then falls to the ground because the gravity, that minus 9.81 meters, is pulling it down. So those are kind of the basic settings that we have with the rigid bodies: mass, its friction with the air, and its resistance to rotation, and whether we use gravity or not. Another property is the kinematic property, and this is whether the object is moving because of physics or whether it's being controlled by keyframe animation or scripting. So an object that is set to be kinematic is not going to fall. Let me turn on gravity and turn off kinematic, and you'll notice that the object falls, as does my bouncing ball. But if I turn on kinematic and run this again, the object doesn't fall. However, it is participating in the physics system, and this means it can affect other physics objects in ways that we'll discuss when we get to colliders. Kinematic is also something that we often access in scripting. So in this next example, I have, let's see, in this next example, I have a rigid body. There we go. That's right there. I have a rigid body that is a projectile beam, and it has an animation on it. I'm animating it with an animator. This is an animation that I set up that's going to move the object from here over to here. It's just going to slide it through space. And you'll notice that I have the is kinematic set on this object. So watch what happens. It moves across the scene, it knocks the block out, and things fall over, and the block ends up sitting over here where its animation ended. Let me run it again, and this time I'm gonna trigger the pause button here so that when I run it, it's going to advance one frame at a time. And so as it moves across by animation, it's being controlled by external to it. And there you can see it has penetrated into this object. In the next frame, it figures out what it's supposed to do, and the collision goes forward, and the things all fall apart and bounce down. Here's a slightly different version of this, where now I'm using that projectile script that I had that gives the object an initial speed. It does this through its rigid body. We'll talk about scripting the rigid body in a bit. And again, let me run this, and you'll see the cube fire across, knock things down. This time, instead of stopping, it bounced off someplace and went where it did. And let me again pause this and step through it one step at a time. And again, here it's penetrated the object. The objects don't really penetrate, but this is what triggers the collision engine that then forces the red block forward, and the little green one falls back down, and the whole system collapses here. So that's the difference. That's where we're using is kinematic. The projectile beam was not is kinematic, whereas the animated one was. If we control it through scripting, or if we control it through an animation, it should be is kinematic. We'll talk more about this later when we get to colliders. Some other settings, there's interpolate or extrapolate. This can help sometimes if you have jittering or shaking with things. It does require extra computation, so it's a performance hit. And we also have two constraints. We can freeze its position, its X, Y, and Z position, in which case an object will not move in that direction. We can also freeze rotation. An object will not rotate about a specific axis. These constraints are here, and we can freeze individually X, Y, and Z position, or X, Y, and Z rotation. For instance, I could freeze the Y position here, and now if I send this thing, it's still going to go, but it's not going to fall in the Y direction. Notice here it is bouncing back, but not falling down. So constraints. Collision detection is something that you sometimes fiddle with if you're using very high velocity objects against stationary objects. This helps with bullets. If we're having trouble with bullets going through objects, we can change the setting from its default discrete to continuous dynamic. Put this on the fast object, and continuous and put this on the target object. And this can sometimes help with collisions. There's also a continuous speculative, which I believe guesses how it's supposed to work. This last property influences the behavior of the update and fixed update functions that we'll later see in scripting. The update function is called every cycle, every frame. When I was doing the pause thing, that was advancing one cycle or one frame. And this is generally throttled at 60 frames per second by something called the VSync. Whereas the fixed update, which calculates the physics, is called at fixed time steps. By default, every 0.2 seconds, which means 50 times per second. And this is also something that's available in the physics settings. You can change that physics time step, make it smaller, which will then cost you more physics computation, but make your physics more accurate, or you can make it bigger, which makes your physics less accurate. I'm going to stop there, and I'll come back and pick up with force. So I'm going to stop sharing here, and I'm going to end this recording. I'll come back and pick up with force and colliders and the other things. So I'll stop now. See you in class. Bye.